Circuit faults within the fuel pressure regulator or suction control valve system can cause stalling, poor engine performance, or even a no-start condition. If this occurs, what should we check for? And what are the steps needed to resolve the problem? G'day, I'm Zach. Welcome to Automate. The suction control valve works in a closed-loop system with a fuel rail pressure sensor, ECM, and injectors. The valve relies on feedback from the rail pressure sensor in order to supply the correct amount of fuel required to keep the rail at its working pressure. The suction control valve regulates the amount of fuel entering the pumping chambers to meet all engine load conditions. The valve receives a duty cycle control from the ECM in order to allow more or less fuel into the pumping chambers. The ECM monitors the fuel rail pressure sensor and suction control valve to determine if the commanded and actual pressures are within a predetermined range. If they fall outside the desired parameters for a predetermined time, a P0090, P0092, or even a signal performance DTC may set. The vehicle may even enter a reduced power mode. Always consult the freeze frame failure records for a more detailed overview of the running conditions at the time of the fault. It's not uncommon for other fuel pressure related codes to set as a result of the P0090 or the P0092, such as fuel rail pressure high and low. For a more detailed description of these systems, please watch our other in-depth diesel training modules. A quick test to perform before condemning the suction control valve, ECM or harness is to confirm the connector is attached to the fuel pressure regulator. Look for any signs of damage to the harness or the connector retaining tab. Next, using a digital multimeter, attach the red meter lead to the ignition supply terminal and the black to the low side control. Now using a scan tool, turn the ignition on and command the regulator on, then off while watching the meter. Ignition voltage should be seen when commanding the regulator on and 0 volts when off. If this test was okay, the only fault would be the control valve itself. If ignition voltage wasn't seen, there may be a short to ground, open, or excess resistance in the circuit. Attach the red meter lead to battery positive and the black to the low side control terminal in the harness connector. Using the scan tool, command the fuel regulator control valve to 100% while watching the meter display. We should see battery voltage. A reading of 0 or substantially less than battery voltage indicates an open or excess resistance. Move the black meter lead to the next inline connector and retest. If correct voltage is now seen, this confirms an open or excess resistance within the first section of the harness. To rule out the connector as the fault, check for terminal tension and corrosion. If this is okay, the open or excess resistance is within the harness. However, if the meter displayed low to 0 volts when testing at the connector, move the black lead to the ECM and back probe the low side control terminal while observing the display. If battery voltage is now seen, this confirms the fault to be within this section of the wiring harness. But if the meter still displayed an incorrect voltage, turn the ignition off, disconnect the ECM harness connector and check for terminal tension and corrosion. If this is okay, the open or excess resistance is within the ECM. With the ignition on and the meter connected between chassis ground and the low side control terminal, any voltage displayed without scan tool activation indicates a short of voltage in the circuit. Disconnect the next inline connector while observing the meter. If the voltage remains, this isolates the short to the first section of the harness. If the voltage was to disappear, move the red lead to the low side control terminal in this connector. If any voltage is now seen, turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on while watching the meter. If the meter displayed any voltage, this localizes the short to this next section of harness. However, if the meter reading dropped to 0, there may be a short in the ECM or a circuit from the ECM. Turn the ignition off and perform a continuity test between the low side control terminal and all other terminals in the ECM connector. If no fault is found, this confirms the short resides in the ECM. When diagnosing these types of faults, make sure you understand the DTC, access and refer to the fuel control data, and always validate the concern. Thanks for watching. See you soon.